Alright, so the last example of a normal distribution case. Again, I'm going to do one of each again. I'm going to do where we have to convert, find a less than, a greater than, a between, and how many. Alright, so this is sort of, again, an example that has a little bit of everything in it. Alright, suppose the body mass index, the BMI, of American men between ages 30 and 50 are normal. And they have a mean, so the body mass index has a mean of 26.2 and a deviation of 4.7. Alright, so that means my mean is 26.2 and my standard deviation is 4.7, which I need for my conversions. Right? Find the percentage of men with a body mass index of less than 25. So less than is the easy case. Right? So if I draw my picture, and I encourage you to draw the pictures, because I think it's just helpful to know how things land. So 26.2 is the mean, so 25 is less than it. And I want to know the percent that's less than that. So this tells me, one of the reasons why I draw the picture, because it kind of gives me an idea of what it should be. So I know that the z-score should come out negative, and 25 is 1.2 units away from the mean, so it's less than one standard deviation, so I actually didn't draw it very well. It actually should be closer here. And so that means it should come out negative, and it should be bigger than a -1. All right, that just kind of gives me sort of my using the rule of thumb to give me knowing. Again, you should always make number sense, so that you know if you get out the right answers. And so the less than's easy because the table percent is my answer. All right, so when I find my z-score and I look up my z-score on my table, it gives me the percent that I'm looking for. All right, so the z-score is my value minus the mean over the standard deviation. So the value is 25 minus the mean, which was 26.2, over the standard deviation, which is 4.7. I already know it's going to come out negative, and it does, because when I take 25 minus 26.2, that's going to give me a negative number. And we always round one decimal place, so this comes out negative 0.26. Do round correctly to negative 0.3. Alright, so that's the z-score that we're going to use. That gives me the exact same area that we're looking for. So because our table is rounded to one decimal place, we always round our z-scores to one decimal place. Alright, so I go to my table and I look up the value at negative 0.3, and that's my answer. Since it's the less than case, the table value is the answer. Alright, so negative 0.3 puts me down here at 38.21%. Alright, so the table percent is the right percent, so 38.21% of men have a body mass index of less than 25. Alright, find the percentage again. Above 28. So I did a less than, now we're doing above. So above we have to do a little more work. Again, write it out so that you can see and understand what's going on. So 26.2 is in the middle. 28 lands above that, and it's not one standard deviation away, so it should be close, and I want the percent above, so the percent I'm looking for is on the above, which means I can't use the table, right? This percent comes from my table, and so to get to the percent I want, I have to take 100% minus the table percent at my z-score, right, when I convert to my z-score. Alright, so when I look my z-score up, that's not the answer. I have to subtract that from 100 to get the answer. Alright, so my z-score is my value, which is 28, my score, minus my mean, which was 26.2, over 4.7. And again, based on what we have here, I know it's going to come out positive, and it should be a positive value less than 1, right, because it's not one standard deviation away. And it does. It comes out 0.38297. Remember, we round to one decimal place because that's what our table has, and so we're going to round this up to 0.4. So my z-score that I'm going to look up my value on my table, which is not my answer, but it's the value I'm going to look up on my table, is at 0.4. So I go to my table, I look up positive 0.4, which comes out to be 65.54. 65.54 is the table value, 65.54, which is this region. That's not the region I want. I want the region left over here, and so I'm going to have to take 100 less than 65.54. And another clue that I need to do that subtraction is, if you'll notice, that's why pictures are always helpful. Because based on the picture, I know that it's above half of the area, and so I know the percent should come out smaller than 1/2, right? Because this is less than half of the area, and so the 65 doesn't make sense. All right, so the 65 doesn't make sense, and so we have to remember to subtract to get the actual percent I want. So take my 100% minus my 65%, and that comes out to be 34.46% of men have a BMI of above 28. Alright, now the hard case. Find the percent between. So we did a below, above, and now a between. So the between case is always the harder case. Alright, so our mean was at 26.2. 27 lands above it, and 22 lands below it. So this is the part that I want. That's the percent that I'm looking for. So there are going to be two z-scores. There's the z-score that goes with the 27. That would be z-score 1. So that's the percent from the table from z-score 1. And then there's the 22. Alright, so z-score 2 and the percent from my table. In order to find the percent that we want, you take the bigger percent, so the percent from z-score 1, and subtract the percent from z-score 2. And always the bigger percent minus the smaller percent. Percent should always come out positive. Alright, so I've got to do two conversions. I've got to look up two table values, and I've got to subtract the two table values. Alright, so the two z-scores. So I'm going to do the z-score with 27 first. I'm going to find my z-score 1, and then my z-score 2. Alright, z-score 1 is my 27 minus my 26.2 divided by my 4.7. Make sure you're careful with your division. And so that comes out to be 0.2. And again, it should be positive because 27 is bigger. It's not a very big number because it's not that far away, right? 27 is not that far away. Alright, so z-score 1 is 0.2. When I look up on my table, z-score 2, which is 22 minus 26.7 over 4.7. And again, this one comes out negative because 22 is less than the mean. Still not a deviation away. Close, but not quite. Alright, or round it to 1. Remember, round to 1 decimal place, so this one rounds to negative 0.9. Alright, so that's the table value I'm going to look up. Alright, so when I go do the subtraction, I'm going to go look at my table values and I'm going to put them in. So I'm going to look at the table value at 0.2 first. That's going to give me the bigger number, so that goes in first. So 0.2, the positive number, 0.2, 57.93. So 57.93. And then negative 0.9 should be the smaller number, negative 0.9, 18.41. And I find the difference, and that's the percent that I'm looking for. So that comes out to be 39.52%. So 39.52% of men will have a BMI of between 22 and 27. Alright, not the last yet. Last two, but I think they go together. Alright, several health organizations have declared that men with a BMI of 35 or greater are obese. Find the percentage of obese men. Alright, so this is a greater than. And it should be a small percentage because 35 is well above the average. So 26.2. That means 35 would be way up here. So it should be a fairly small percentage. Remember, when we look up the z-score on the table is going to give us the percent below, which should be a fairly big percent. We want the percent above. So when we find the percent above, we're going to take 100% minus the table percent to get our answer. Alright, but before we get there, we have to convert. So our z-score, which is 35, our mean, which was 26.2, I didn't give myself a whole lot of room to write here, divided by 4.7. Again, round to the whole number, which again, I know it's going to be over 1. 35 is over 1. It looks like it's pretty close to 2, so it should be close to 2 standard deviations, I believe. Alright, so we're going to take our 35 minus our 26.2 divided by our 4.7. It is close. It comes out 1.87, so I'm going to round to 1.9, or round to 1 decimal place. And so that's the table value we're going to look up. So 1.9. That's going to give us the percent below 1.9, which is a big percentage, 97.13, so most are below that. So the table value is 97.13%. 97.13 if you can't read that. And so to find our actual value, though, we take 100% minus the 97.13. So 97.13% of men have a BMI less than that. So to find those that have it more than that, you subtract it from 100. So you're going to take that 97.13 minus 100. That'll give me the answer we're looking for. All right, that answer comes out. And again, it should be small. 2.87%. So less than 3% of men have a BMI index of 35 or greater. So based on the Health Organization, about 3% of men are obese, right, based on these numbers. The last one then is then to ask you how many, right? So we did, again, this one kind of walks you through every single type of example. Right, less than, greater than, between, and then how many. So remember, when we find out how many, you take your percent as a decimal, don't forget as a decimal, multiply it by the size of the group. And so in this case, the decimal is, you divide your percent by 100, in case you don't know how to convert. 2.287 divided by 100 is going to come out 0.0287, exactly, times the 2,500, and so we get, and again, round to the whole person, this comes out 71.75. We don't want to 3/4 of a person, so round up to 72 men. More specifically is how many. Again, approximately, because we did round a bit. And it is based on estimates because it's based on table values anyway. So about 72 men out of 2,500 we would expect to be obese. Alright, that finishes up 6.2. One more section to go in chapter 6. Alright, so 6.2. Make sure you're careful and make sure you remember you have to use the tables. You have to convert to z-scores, you have to round to one decimal place, and you have to use the tables in order to solve the problems in the homework for normal curves, on the quiz for normal curves, and on the exam for normal curves. Alright, so make sure you know how to use the table because you have to. We'll stop there.